Hi guys, so question of the day is, can square root of 2 plus x and square root of 2 minus x both be rational numbers, no matter what x is? That is the question, and I'm going to answer it to you. The answer is no, and I'm going to show you why. So, okay, generally when thinking about if anything is irrational or something, if any expression can ever be rational or irrational, a very common way to deal with this is a proof by contradiction. So I'm claiming that at least one of these are irrational. So therefore we assume that both are rational, meaning that we can write square root of 2 plus x as a over b and square root of 2 minus x as c over d when a, b, c, and d are integers. Yes, when a, b, and c, and d are integers. So this is our expression. And what do we do with this? This problem is actually really easy. So what do we do here? If you know your Gauss elimination, maybe you've taken some linear algebra, you would instantly see that if we just add this row onto that row, the x's would disappear. So let's do that. What do we get then? We get that 2 square root of 2 is equal to a over b plus c over d. Okay, and what do we do here? Okay, so we want to isolate the square root, because, okay, here what we want to do is want to arrive at an expression where we have a clearly irrational thing on the left-hand side and a clearly rational thing on the right-hand side. And then we have concluded our point. So let's just divide. We can just start by, we'll start by fixing this right-hand side. Okay, so how can we rewrite this with the common denominator? Well, you do these, we multiply by d, both of them, and multiply both of these by b. What do we get then? We get AD over BD plus C, right? CB over BD again, which is just equal to AD plus BC over BD. And here, okay, so now we have a 2 square root of 2 and we have this thing here. And then we just divide by 2 by both sides. So this thing means that square root of 2 is equal to AD plus BC over 2BD. And here, let's think. Okay, a rational number is a number which can be described as an integer divided by another integer. Okay, here we have an integer times an integer plus an integer times an integer again. And then we have divided by 2 times an integer times an integer. So the denominator is an integer, and this is also an integer. So therefore, this is a rational number. You do it like this or something, yeah. So therefore, this is a rational number, which then says that square root of 2 is a rational number, and we know that's not the case. So therefore, this is not true, and we have arrived at our contradiction. So yeah, that was it. Thank you so much. Bye.